Ever pondered over what lies at the heart of calculus? The answer is a seemingly simple yet profoundly powerful concept: the limit. Imagine standing at the edge of a cliff, peering into the vast expanse of the mathematical landscape. The limit is the concept that allows us to step to the very edge, to peer into the abyss of infinity, and to make sense of what we see. So, what is a limit? At its core, it's about approaching. Whether we're talking about a function inching closer and closer to a particular value or a sequence of numbers marching steadily towards infinity, limits help us understand what happens as we get closer and closer without actually reaching our destination. But the concept of limit is not just about getting closer. It's wrapped in a layer of precision, defined by two formal definitions. For functions, we have the epsilon delta definition. This states that for any small positive gap we want around a specific limit point, we can always find a range around our input value, such that any input within that range will produce an output that stays within our chosen gap. In other words, we can get as close as we want to our limit as long as we're willing to restrict our inputs. For sequences, we turn to the epsilon in definition. It communicates a similar idea. No matter how small a gap we want around our limit, we can always find a point in the sequence beyond which all terms stay within our chosen gap. This ensures that as our sequence progresses, it eventually settles in near our limit. But why do limits matter? Why should we care about this mathematical concept? The significance of limits extends far beyond their formal definitions. They provide a solid foundation for calculus, underpinning the concepts of continuity, derivatives, and integrals. They serve as a bridge between the finite and infinite, enabling us to tackle complex problems and model diverse phenomena ranging from population growth to the behavior of electrical circuits. In essence, limits become our lens, our language, through which we describe and analyze change, motion, and accumulation. They open up a world of possibilities, enabling us to explore the mathematical landscape with newfound clarity and depth. So embark on this journey of exploration. Delve into the concept of limits, and unlock a universe of mathematical beauty and practical applications. Remember, understanding limits is more than just memorizing definitions or manipulating symbols. It's about appreciating the elegance and power hidden within seemingly abstract concepts. It's about unraveling the threads that weave together the fabric of calculus and analysis. And most importantly, it's about standing at the edge of that mathematical cliff, peering into the abyss of infinity and making sense of what we see. The limit, in all its simplicity and complexity, is the key to that understanding.